Okay, I'm going to attempt to show you how to flash these boards. This is a 1.3 that's basically my development and test one. It's one of the very first ones that I built. I've completely erased the firmware in it, so there's nothing in it right now. A couple of points you'll see. Let me find something I can use as a pointer here. You'll see that these two sets of pins are unjumpered. The top two sets of pins are the boot 0 set. The bottom two sets of pins are the reset. And they are to be jumpered from right to left across those pins. So if you were to jumper them, you'd put the jumpers on that way on both sets of pins. I'm just going to leave them off right now so that I can show you how you can power these boards, okay? So the boards can be powered one of three different ways. The 1.3s, let's try a different way. The 1.2s, I'll try to distinguish between the two. 1.3s can be powered simply by plugging in a USB port. So if you plug in a USB port, you should simply see that blue LED right there. Hopefully you can see it, or at least see the color of it, because it's sort of hidden in the camera. You can see that blue LED is lit. Okay, that's one way you can power a 1.3 board. Okay, you can also power a 1.3 board with a USB serial adapter. This is a 3.3 volt USB serial adapter that I use all the time. It's got the connector on it for a 1.3 board. I purposely disconnected the two serial RX and TX, so all I have is 3.3 and ground connected to it. So if I plug that in and I plug USB into the USB serial adapter, you'll see that the LED comes on again, and if you listened in the background, you probably heard the Windows detected the USB serial adapter. Okay, so that's the second way you can power a 1, and that will work for either 1.2 or 1.3. Now the third way you can power it, but I don't want to do that right now because there's no firmware in this board, is via the plus and minus pins right here on the controller itself, and that would require a LiPo to power it, but we're not going to do that right now. Okay, so let's assume this has firmware or not. I don't really care. Let's flash the latest firmware to it. And while I do that, actually I'm just going to shut you off a minute while I go set up, so you don't have to wait for me to go find the flash file. Okay, I'm back. Alright, the first thing we're going to do is we're going to put a jumper on the boot 0 pins. The next thing we're going to do, and you see that I pushed that down on the pins. The next thing we're going to do is we're going to put a jumper, and I'm just going to lightly set it on those pins. I'm not going to press it down on those. Okay? On the reset pins. Then you're going to connect all four of the wires on the USB serial adapter. So you saw that I had voltage and ground connected. I'm going to go ahead and connect the TX pin and the RX pin. So I've got ground, 3.3, TX, and RX connected, and they're crossed because I know that this adapter has the correct pinout on it, so I want TX on this adapter to RX on the board, and I want RX on the board to TX on this adapter. Some of the CP2102s are mismarked on the board, and you have to connect them TX to TX and RX to RX. Okay, so let's plug this back into the UART1. And you can see that I have nothing connected to LiPo. That's rule number 1. Anything connected to the UART1 connection, nothing connected to the LiPo connection. All right. So we're going to go ahead and now power it with USB. Or excuse me, we're going to plug in our USB serial adapter. You heard Windows detect it. Okay, this is what the flash demonstrator looks like. I know that I'm connected to COM port 3, which is my USB serial adapter. You can see I'm at 115.2, even parity, disabled, and 5 on the timeout. Now I'm running the 2.2 version of this tool. There's a much later, more recent version, 2.6, but for some reason it doesn't like to run on this PC, so I have to use the 2.2. But they're similar enough that the same holds true. So I'm connected to it. USB serial's connected to it. I'm on UART1. Nothing is connected to the LiPo port. I'm going to just jiggle that reset button, and then I'm going to click next. You'll see the traffic light is up. That says that the board, the little processor, is in the right mode, that the software can talk to it. We're going to click next. You'll see that it detects it's a 256K processor. You can ignore all this stuff. It's just the pages of memory that are there. Whether they're locked or not, you can protect memory if you want to. We're going to select next. Download device. We're going to go to the my directory is called EvvGC, built versions 4.0. I want a hex file, and I want the STM32 gimbal. So I select that as a .hex. I've got global erase set. You can just have the erase necessary pages. Make sure you don't have the no erase set. And then I have optimize, remove some FFs, and verify after downloading. And if I click next right now, I will flash that file. You'll see it flashes. In this case it's 62K, 60K basically, rounded to K. It'll download it to it, which is sort of a backwards term. It's taking it from the PC, putting it on the processor, then it will verify that that download worked correctly. And then we'll close it. I'm going to disconnect my USB serial adapter. You'll see the power light go out. I'm going to remove this jumper on boot 0. And now when I plug in, I should see the board come up. You see the green LEDs flash. And then you see an error condition, okay? You see the rightmost green LED is lit. That's really the debug LED that tells me there's an error condition. And the left LED, which if you had a 1.2 board, you'd only have this left LED, it's blinking. That tells me that there's not an IMU connected, okay? Now, it used to be, until I made a change in the code today, that I could go ahead and connect one and that light would go out. That's no longer the case. If we want to remedy this error, we'll have to unpower the board. We'll connect our IMU. And now we'll repower the board, and you'll see a different light sequence. LEDs are blinking out. It's going through that 20-second change that I added today while it stabilizes the gimbal and waits for the IMU to... Then we should see the left LED come on. Unless I broke something. So the left LED comes on, and it's not blinking. The right LED is out and the power LED is on. And at this point in time, the board is functional. It's got, you know, it hasn't obviously, well, it has my EEPROM right there. This is the EEPROM chip itself. It's got the values in it that it had prior, but this board is functional, okay? So I can power this board. It's a 1.3. I can go ahead and remove this and power it this way, and I'll see exactly the same situation happen. I guess I'll shorten that timer that I put in for Waiting for the gimbal to stabilize. Okay, so now we're running off of USB power. Or for that matter, if I disconnect USB and I plug in LiPo, I don't have anything connected to UART1. If I plug in LiPo right now, I'll see the exact same thing. Power lights come up, blinks the 20 times there on both LEDs, goes to a dark for 20 seconds. And then the green LED will come on. If the green LED doesn't come on and it just blinks, then that means that there's an IMU problem. Okay? That's really as basic as it is to flash one of these.